Hey class, in this video, we're going to look at the basic concept of reducing a square root. Okay, so the first example is the square root of 20. So if I grab my calculator and type in square root of 20, you can see it gives me a long decimal. So what that means is that 20 is not a perfect square. It didn't give me a whole number. So what I want to do is find the perfect square that goes into 20. And to do that, I need to know what my perfect squares are. So in the top right hand corner, I'm going to write out the first few perfect squares. So 2 times 2 is 4. So 4 is the first perfect square that we would use. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8, 64. And they keep going forever. All right, so these are your perfect squares. And remember that this list keeps going. Okay, so now I go back to this first example, the square root of 20. And I want to find out which one of these perfect squares goes into 20, or which one of these is a factor. So I notice that 4 goes into 20. So I can rewrite 20 as 4 times 5. 4 times 5 still gives me 20, so I haven't changed it, I just rewrote it. So now the square root of 4 is 2. So what I want to do is mark out the 4, because I'm taking the square root of it. Put a 2 on the outside. Square root of 4 was 2. The 5 isn't a perfect square, so that has to stay under the square root. And that's all I can do. So the answer is 2 square root of 5. I want to do the same thing with the square root of 50. You can go to your calculator, square root of 50. You can see it gives you a long decimal, so it's not a perfect square. Then you want to look and see if any of these perfect squares can go into it. In this case, 25 goes into 50. So I can rewrite 50 as 25 times 2. The square root of 25 is 5, so a 5 comes to the outside. And leaves me with a 2 underneath. And if you ever want to check yourself, so I see the square root of 50 gave me 7.07106. If I type in 5 square root of 2, it should give me the exact same decimal. So we're not changing it, we're just reducing it. So that's the way you can check yourself. Next example, we have the square root of 128. And this one's a little bit different because in the first two, we only have one perfect square that goes into it. But this one has a couple different perfect squares that can go into it. But there's no right or wrong one to use. So 128, I'm going to try 4. So I can see 128, or 4 goes into 128 32 times. So I can rewrite that as 4 times 32. Square root of 4 is 2. Okay, but if I use 4 and 32, then I always have to ask myself again, can the square root of 32 be reduced? And in this case, it can. 16 goes into 32, so I have to repeat the process again. So I'm going to rewrite 32 as 16 times 2. All right, the square root of 16 is 4, so I'm going to mark out the 16. A 4 comes to the outside, the 2 comes down, and the square root of 2 stays, or the other 2 stays underneath the square root. So now I have the 4 and the 2 on the outside. I want to multiply those two numbers, and that gives me 8 times the square root of 2. And you know you're done because the square root of 2 doesn't have a perfect square that can go into it. So that's how you know you've reduced it all the way. So your answer is 8 square root of 2. So that one took me a couple different steps. The reason why is because I used 4 to start with, which is a perfect square. But if I would use the biggest perfect square that goes into 128, in this case, which would be 64, if I would have started by saying 128 is 64 times 2, okay, then the square root of 64 is 8, so I would have pulled out an 8, the 2 stays underneath, I would have got 8 square root of 2. So, same answer, this one took a couple steps, this one only took one step. So you don't always have to use the biggest perfect square, but if you do use the biggest perfect square, then you're done after one step. If the smaller perfect square, 4, jumps out at you, it doesn't mean that you're wrong. Just when you get the square root of 32, you need to ask yourself, is there a perfect square that can go into this number? Okay. So here, I actually have the square root of 32, so we kind of already did it. So I'm going to notice I could go 2 different routes here. I could say 32 is 4 times 8, where the square root of 4 is 2. It leaves me 2 times square root of 8. But then I noticed that 8 has a perfect square that can go in it, 4. So I could rewrite that as 4 times 2. The square root of 4 is 2, so bring out a 2. 2 times 2 is 4. And the other 2 stays underneath the square root. I could have went that route. The easier route would have been to use the square root of 16. So I could have said 32 is 16 times 2. The square root of 16 is 4. And the 2 stays underneath your square root. So that gives you 4 square root of 2. So once again, same answer, just 2 different ways to get to it. So what if I have the square root of 10? Okay, so this time, if I type in my calculator, square root of 10, it gives me a decimal. But when I look for a perfect square that can go into 10, none of these numbers can be multiplied by anything to give me 10. I'm sorry you couldn't see them. So this time, even though it's not a perfect square, there's no perfect squares that can go into it, so that one can't be reduced. So the square root of 10 couldn't be reduced, so you would just have to leave it as square root of 10.